The amygdala, a small almond-shaped structure nestled deep within our brain's temporal lobes, acts as the primary alarm system, hardwired to detect and process emotional salience, especially fear and threat. When confronted with a dangerous or painful situation, the amygdala kicks into overdrive, triggering a cascade of neurochemical responses, including the release of stress hormones like cortisol and adrenaline. This potent cocktail doesn't just prepare the body for fight or flight, it also marks the memory of that event as critically important, ensuring its robust encoding and long-term retention. This biological imperative means that evolution has favored remembering what hurts us over what pleases us, because survival often hinges on avoiding past dangers rather than reliving past joys. The heightened emotional state during a traumatic event essentially puts a bold tag on that memory, making it stand out in the vast library of our experiences. Consider the phenomenon of flashbulb memories, vivid, detailed, and seemingly indelible recollections of highly emotional or surprising events, such as a major public tragedy or a personal crisis. These aren't just strong memories, they're almost photograph-like in their clarity. And while they can occur with positive events, they are far more commonly associated with moments of shock, fear, or profound sadness. This mnemonic advantage for negative experiences stems from their direct relevance to our survival. Learning from a negative outcome, like touching a hot stove or being bitten by a venomous insect, provides crucial adaptive information. The brain prioritizes these lessons, ensuring that we remember what to avoid to prevent future harm, a more pressing concern for our continued existence than remembering the exact details of a particularly good meal. Beyond mere encoding, our brains also tend to dwell on negative experiences more, engaging in a process known as rumination. When something bad happens, we often replay the event in our minds, analyzing what went wrong, what could have been done differently, and the potential implications. This continuous mental rehashing strengthens the neural pathways associated with that memory, making it more accessible and vivid over time. In contrast, while happy memories are cherished, they rarely trigger the same intense analytical reevaluation. A joyful moment, once experienced, often stands on its own, not requiring repeated mental reconstruction for survival or problem solving. This difference in post-event processing significantly contributes to the disproportionate recall of painful events, as the sheer act of thinking about them reinforces their presence in our minds. The concept of the hedonic treadmill further illuminates this imbalance. Humans possess a remarkable ability to adapt to both positive and negative circumstances, returning to a baseline level of happiness over time. However, this adaptation isn't perfectly symmetrical. While we quickly habituate to positive changes, the joy of a new car or a promotion often fades, the impact of negative events can linger far longer. A painful breakup or a significant financial loss tends to have a more sustained emotional footprint, requiring more mental effort and time to process and integrate. This asymmetry in adaptation means that the brain might be more primed to register and remember deviations from a positive baseline, especially if those deviations are negative, as they represent a potential threat to our well-being that needs to be addressed. We inherently value the absence of pain more intensely than the presence of pleasure, making the former more memorable. Finally, the retrieval of memories is heavily influenced by context and the cues available at the time of recall. Negative experiences often come with a rich, unique set of sensory and emotional cues. The specific sights, sounds, smells, and internal feelings associated with a traumatic event are often distinctive and highly vivid, acting as powerful hooks for retrieval. In contrast, many happy memories, while pleasant, might be more diffuse or share similar contexts, making them less distinct and harder to pinpoint with specific cues. Think of the unique, jarring sensation of a sudden injury versus the pleasant but perhaps less individually distinct feeling of a sunny afternoon spent with friends. The starkness of negative events creates a more robust and easily accessible retrieval pathway, almost like a singular, brightly lit path in a dense forest. While positive memories might be a network of many, similar, less distinct trails. This isn't to say positive memories aren't important, but their retrieval might require more deliberate effort or a broader set of associated cues to surface.